This is problem number 1 on the inclined planes assignment. For all problems, you're going to want to start with a free body diagram. So I'm going to represent my student with a dot, and then I'm going to put all the forces acting on that dot. I know force of gravity always straight down. I know my normal force is perpendicular to my surface, and for this problem, we don't have any friction to begin with. After that, I'm going to include a very light sketch of my coordinate system. So for inclined planes problem, you always want to tilt your coordinate system. So I'm going to draw in a semi-straight line. So this is going to be my new y-axis, and this is going to be my new x-axis. So I'm going to put a little x and put a little y. Remember that the angle of incline is always equal to the angle between the force of gravity and your y coordinate system. So I'm going to draw in my little triangle. This is the y component of gravity. This is the x component of gravity that's parallel to the x-axis. So because this is opposite, this is mg, which is your hypotenuse, times sine. Because this is adjacent, this is hypotenuse, which is mg, times cosine. And then I'm going to write the sum of my forces. So looking at my picture, I know that this and this are in the y direction. So I'm going to write the sum of the forces in the y direction is my normal force, positive because it's going up, and my force of gravity, which the component of gravity, which is mg cosine, which is going down. And then it's not accelerating in the y direction, it's not accelerating up or down the ramp, or into or out of the ramp, so that's equal to 0. And then I'm going to write the sum of the forces in the x direction, which in this case is only this mg sign. So I'm going to write the sum of the forces in the x direction, and I only have mg sign. Because it is unbalanced in the x direction, it has to be accelerating in the x direction, so this is equal to m times a. So then part A asks you to solve for your normal force. So my normal force is found in the sum of the forces in the y direction equation, so I'm going to use that one. So it was initially going down the ramp, but now it is going, now that there's friction, in order to make it accelerate at the same rate, we have to now apply a downward force. So we now have force down the ramp, mg sine down the ramp, and friction up the ramp. And again, we want to try to make it accelerate at the same rate, so A is going to be the same as it was earlier, and so we want to solve for the new F. D is now asking for the coefficient of kinetic friction. That is mu. And so we only have one equation for mu. And that is my frictional force equals my coefficient times my normal force. Now I solved for my normal force earlier. It gave me my frictional force, so really I just need to divide the two numbers. So I have my frictional force was 3 newtons. My normal force from earlier was 519.3. This is from part A. And I get a coefficient of 0.006, I believe. Double check me on this calculation because I know the answer on the answer sheet was wrong, but this should be the right number, I believe. Okay, good luck.